Hi guys, welcome back to my channel. Welcome back to yet another video, and today we'll be looking at the ESS topic 2.5, investigating ecosystems. The subtopic that we'll be looking at in today's video is going to be the Lincoln Index. So without any further ado, let's get started. Before I start with explaining you guys the Lincoln Index, I want you guys to know, please keep in mind the IB experimentation policy with the experiment and with whatever we'll be looking at in today's video. I have already talked about the IB experimentation policy in my previous video of 2.5 chapter, and I've explained what all the IB experimentation policy contains. So go and have a look at the part 1, and let's now begin with the part 2 of Lincoln Index. So, Lincoln Index is mostly used to measure abundance of mobile organisms that are moving organisms. So, it's also called the capture, mark, recapture method, and I'll talk about that in a little detail now before I look at the formula. Here, you all can see that it says capture, mark, and recapture. So let's look at it. So what you got to do is you have to capture the organism first, and keep in mind capturing the organism will be different for every type of animal that you're capturing. You cannot have the same type of method for every animal that you're trying to, mark, or every species that you're trying to capture. Not only that, when you write this particular, the other name, it is also sometimes called capture, mark. Here, over here, we have another word which is called release. You can have another word over here, release. This one, it's right over here. So you can have capture, mark, release, recapture also. But both of the ways it's right. So you guys can write anything. And let's move forward. So what you do is you capture a certain amount of the animals, whichever come to hand, and then you count them, right? And you count them. Just after that, you mark them. You mark the captured animals, and you have to take certain precautions because of the IB experimentation policy. You have to take certain precautions. For example, the mark that you make should not be toxic for the organism. It should be semi-permanent, and it should not also harm the organism. After you've done that, after you've marked the organism, you have to release the animal, the organism, into its environment. Not only that, remember, you also have to give it enough time to disperse and, of course, get mixed with the remaining population. The time before you do another capture will depend on the mobility of the organism, whether it is R or K strategy. So, once you're done with that, once you've given it enough time to mix and disperse, you then recapture the organisms, and now you have to check the animals which have been captured on both occasions, which have been marked already, and the organisms that haven't been marked, which you just caught for the first time. It's not caught on both occasions, it's the first occasion, which is being caught on. So there can be both type of organisms, marked and unmarked. So you have to keep that in mind when you're doing this experiment. Now, coming back to the particular formula that we had, you need to, now it'll be easier for you to understand because it's gonna really, make it better for you because we've already talked about the mark, capture, recapture, release in more detail. Okay, let's now try to understand this. Now, to understand the formula better, I will explain you guys every variable that we have. But when I do that, you have to keep in mind whenever you calculate this formula, you always need to mention the date and time of the investigation and experiment. Whenever it has taken place, please mention the date and time, as this result and this experiment is dynamic. Now, coming back to the formula, N1 is for the number of the species which have been caught in the first first, I would say, first attempt or first capture, okay, or the first sample. N2 is for the number of species which have been caught in the second sample. NM is the number marked on the second sample. Sorry, just give me a second. Which in this case will be 2. So let's now try to understand this using an example. But I hope you guys understood the formula as of now, and we will also evaluate this particular Lincoln index. The assumptions of using Lincoln index. The population of organisms must be close as there is no immigration or emigration taking place. Not only that, the time between the samples that have been taken also must be small to the lifespan of the organism. For example, if, for example, there's such a species which has a lifespan of a month, so now of 30 days, for instance. So now you cannot have a 2 month time span gap or the time gap between the marks and the captures that you take, the samples that you take, because the species will no longer be there because its lifespan is already just 1 month and you can't take 2 months. So you have to already know that what is the lifespan of the species, and you have to compare your time samples, which must be small compared to the lifespan of the organism. Also, the marked organism must mix completely with the rest of the population during the time between the sampling, which I also mentioned previously that you have to give them enough time to disperse and get mixed in the remaining population when you release the animal. Okay, now let's move forward. Now, looking at the certain possible sources of error with when you do the Lincoln index, when you do the capture, mark, release, recapture, funda. So you have to know this. The immigration and emigration can actually lead to a great amount of error. Also, natural disasters or disturbance between the captures can lead to a disturbance. Had trap happy or trap shy individuals. Organisms did not have enough time to disperse back into their ecosystem. Also, animals have lost the marks between the captures. The mark that you make on the animal is no more there till the next capture, the recapture that happens. That also can make the outcome really inaccurate. Now let's try and look at one example so that this is much more clear to you all. So here is an example. To use the Lincoln index, in a woodland, the undergrowth was sampled for snails and 430 were found unmarked. They were released and the population similarly sampled after a 2 week period. The second sampling produced 410 nails, 100 of which were marked. So now we know that 100, so the marked ones we have is 100 of which were marked. So the marked ones are 100, right? The unmarked ones, I'll just take this, the unmarked ones are 410 minus 100, which will be 310, right? 310. Moving forward, we already looked at this. N1 in this case will be 430 because the first capture we had 430 snails captured. Second capture we had only 410. The marked ones, the ones which were marked on both occasions, we already looked over here. So the ones which were marked, and because they're marked because they were captured on both occasions. They were captured even when, in the first time even in this first sample they were captured, as well as in the second sample they were captured. So then it is the This is the one which I captured on both occasions. Okay. So what you will do is the formula is N1 into N2 by M2. So you will write 430 into 410 by 100, which will give you 1763 snails. That's an estimated population of snails. Okay. So now let's use another example. While studying field voles, an ecologist caught 500 and ringed a foot of each before releasing them. You've marked it also now because you've ringed the foot. Now, every day for the next 2 weeks, he examined the waste material found in their nest of their predators. He collected a total of 300 field vole skulls and 15 rings. How many field voles were examined were probably in the area examined. So how many of voles were there in the area which we were actually trying to see? So you all can see here, you have to do 300 because that's what you guys got, right? 300 is the next one, the next attempt, I'll say. So 300 into the first attempt, which is 500, into 15 of the ones, which is the rings. That means that the first time also they were captured when the rings were, put on them, and the second time also they were captured when the ring was found in them. So that becomes them being captured at both these situations, both the occasions. Hence, this becomes 300 into 500 by 15, which is 10,000 volts population. Now, you all can try this question, and if you have any doubts, any questions related to Lincoln Index, don't forget to put them down into the comment section, and I'll surely check that out. Also, don't forget to like my video, subscribe to my channel, and also don't forget to put the bell icon on so that you guys can receive the notifications of my videos ASAP. Bye bye, and have a really nice day.